before that, we will look at the features and the important parts of the retaining anchor walls. This will be, as you can see here, in terms of the categories, we can have the anchor earth wall fixed earth support, and also we have a free earth support. So what are differences between these two things? Before that, the important parts about the anchor earth wall or whatever it is, you have to understand the theoretical behind it. For example, the types of anchor earth wall, mode of constructions, the stability, modes of failures, and the highlight for this course is the design of proper sheet pile wall for free and fixed earth methods, and the effect of power to pressure distribution, seepage, and anchorage. Yeah, wait a second. Okay, back to just now. So apa yang kita nak tengok adalah kalau you present in currently there's a major structures project in the big capitals town. So some the projects involved is the deep excavations. You like it or not, whenever it comes to the deep excavations, this is the time where the retaining wall is required to retain the soils behind or in front of the wall. So the purpose of this one to provide stability of the structure. So just imagine if you doing constructions in deep or underground without having the retaining wall, there will be some loss in life and also loss in the structural damage, etc. So it is very important to understand the first things on the what we say the features of the applications of the retaining wall, and then the modes of construction as well as the failures, and also you need to of course lah to know how to design for different type of retaining walls, because as you refresh balik from the previous topics is on about the embedded cantilever wall. There are standards of requirement for different approach you opt to do in your design and analyze. Same goes to the anchor as well, that you need to look careful what are the things that need to be considered as an important criteria, important point before you doing the design and analysis. So for example, in a deep excavations, this is where it is a purpose to retain larger heights of soil compared to that of a cantilever wall. So the sheet pile walls need to be propped or anchored. So yang ni yang saya idealisekan kalau you look at to any figures, images yang melibatkan a few meter deep from the ground surface. Kat situ memang nak tak nak macam mana you kena tahan tanah menggunakan tembok penahan dengan you strengthenkan using another structure. Kat situ kita panggil dia sebagai propped or anchor. Multiple prop and anchor sheet pile walls typically used in the deep excavations. And then when you have a area site project and next to next adalah existing buildings. So there's a chance that yang mana kalau kita tak provide a good design and analysis for the retaining wall we have chosen, there will be some damages to the next buildings in our site projects. So it is very important lah untuk you understand the theoretically, kemudian dia punya type, dia punya application, etc. So however, the earth pressure behind and in front of wall always never come close to fully active or passive under working loads. Hence, they are not analysed using limit equilibrium or classical earth pressure theories. The single probe or anchor shaped by walls may still be analysed without resorting to numerical or finite elements method. So kalau yang simple case tu still can calculate manually lah, tapi kalau dia melibatkan complex analysis, so yang ni comes to you dengan tool or additional software untuk helps you in the analysis and designs. So this is one example for anchor as well. Kita ada single prop walls. So it is often propped near the top and they use extensively with tieback in waterfront constructions. So ini adalah salah satu contoh. Kalau nampak sini, this is I said as an additional structure yang kita apply to the returning wall. Dan some sort of this kind, you can imagine applications there, the purpose of the returning wall, tujuan dia untuk apa. So the tie backs high tensile steel cables or rod anchors in the soil distance behind the wall. So yang ni kita apply dekat bahagian belakang tembok penahan. So there are two modes of construction. You can have as a excavated wall ataupun by backfill wall. So constructed by driving a row of sheet piling on the required line, followed by excavation or dragging to the required depth in front of the sheet piles. Or you can construct it by partial driving in level ground and backfilling to the required height behind the piling. So in terms of the stability, yang ni pun as I mentioned last time, bila kita analyse a returning wall sama ada prop ataupun embedded wall, stability benda yang memang tak boleh avoid lah. Somehow bila you orang kata apa, just recall balik our last lecture on the gross pressure method, yang mana factor of safety 2.0 already inserted in the pressure diagram, passive pressure diagram. So this is the case, the requirement when you adopt for the cross pressure method to analyze the returning wall. But somehow for this course, dia tak extend to you untuk calculate ataupun determine the stability by checking the FOS lah. So by passive resistance developed in front of the wall together with the forces in the tiles of prop. So yang ni yang dia mention to you, kalau you ada prop or anchor on top of this returning wall, kemudian kita dah ada pressure diagram ni, memang because of dia ada backfilling kat belakang returning wall. In front of wall pun still kita ada excavated soil. So there's a thing yang you boleh tengok pada pressure diagram lah dekat active zone, and then the factor passive pressure diagram, and this is the full passive pressure diagram. It's some sort that similar to the gross pressure method yang mana kita dah factorizekan nilai passive pressure. Yeah. And for another things untuk different ways kalau kata kita nak tengok the actual stress distributions, this is the exactly happen on sites lah bila you apply dia punya structure of the prop or anchor wall. How about the failure? The failure is quite similar. Kalau kata you letak retaining wall, dia akan berlaku rotations, kemudian dia akan berlaku sliding, dia boleh berlaku bearing capacity. Okay, sorry sebab apa anak saya tak sihat jadi saya terpaksa apa tengok dia sekejap-sekejap macam tu. Okay, untuk anchor a wall untuk prop sheet pile walls, ini adalah possibility failures yang boleh berlaku bila apa kata ada retaining wall, kemudian kita letak additional structure as a steel bar here. So they can have a rotation about the base as you can see here, and also rotation about the top, and then a deep seated slip. Okay. Kemudian selain daripada tu, kalau you want to see the comparison between the fixed earth dan juga free earth, because as you remember that awal-awal slide tu saya dah tunjuk anchor earth wall ni can be split categorized into two types, sama ada fixed earth ataupun free earth. Tang mana yang kita sebut dia sebagai fixed earth, kat mana yang kita boleh sebut dia free earth. Of course bila all these things dia melibatkan the bending ataupun the moment act to the structure. Ada moment dia boleh move or it can rotate easily. Ada moment kalau sebabkan dia fixed, so dia tak boleh berlakunya rotations. As well as if you look at some comparison kalau kata kita tengok on top of here between fixed earth dan juga free earth, macam yang ni dia punya fixed earth rotation dekat bottom kan, so dia boleh berlaku rotation dekat bahagian atas. Kalau kata free earth kat sini, dekat bahagian atas ni dia fix, dia dah ada satu structure still here, tapi dekat bawah dia tak letak apa-apa structure, so possibility untuk rotate dia berlaku at here. So that's why it called as a free earth. Yang ni yang dipanggil sebagai fixed earth untuk berlakunya moment. And then bila talking about the bending failure untuk fixed earth dia boleh happen at these positions like this how it acts. Tapi kalau you ada free earth dengan anchor pull up, yang ni adalah possibility berlakunya bending failure. And then for the next one is about the base heave, kemudian the prop failure. Boleh jadi masa you apply the steel reinforcement tu, tiba-tiba steel bar tu boleh patah due to some reasons ataupun moment force yang you apply to the structure. Okay, itu antara benda-benda penting lah. So the next one kita pergi kepada designs of prop sheet pile walls. Dalam design dia ada dua jenis lah, kita akan tengok untuk free earth dan juga fixed earth. So what is about design? Design is kalau you look at to the single prop wall with the influence of base fixity. Base fixity ni tengok sama ada dia punya base ni kita fix dia ataupun tidak. Kalau dia tak fix, maknanya dia boleh berlaku rotation. Kalau dia fix, dia tak boleh berlakunya rotations. So the difference between the two conditions lie in the degree of rotational fixity at the bottom end of the wall. Itu yang maksud dia. Okay, kita pergi kepada prop sheet pile wall comparison antara free earth method dan juga fixed earth method. This method is based on the assumption that the soil into which the lower end of the piling is driven is incapable of producing effective restraint from passive pressure to the extent necessary to induce negative bending moment. Itu yang highlighted for category under free earth method. So kalau kata tengok perbandingan antara free dan fixed earth method, first you can see to the mode of constructions lah. Satu dia through the driven pile. Satu lagi dia melalui excavations. So macam fixed earth, the piling is driven deep enough, so the soil under the line of this excavation provide the required restraint against deformation and rotations. Maksudnya in this part ni, the lower end of the piling is essentially fixed. Maknanya bila kita dah fix dia dah duduk dalam keadaan in the position is lah, kita dah lock dia, so kat situ tak boleh berlakunya rotation. That's why it called as a fixed earth. It means that kalau you do the calculations at the base of wall, dia punya conditions moment is equal to 0. So dia tak ada moment lah untuk berlakunya rotations. Okay, ini adalah the pressure diagrams untuk situations where you have the free earth support for anchor sheet pile walls dan juga dia punya pressure diagram. So what is the T? T ini adalah anchor yang kita letak pada sheet pile walls tu. As I said lah, some sort of the steel reinforcement lah. You letak kat dia, dia can produce satu force iaitu T. T tu nanti yang you kena design lah untuk calculate berapa nilai T untuk sustain dia punya stability, strain from failure. Okay, this is the conditions yang mungkin boleh berlaku most of the failure untuk the anchor sheet pile wall. For example here, untuk free earth method, no rotational fixity at the base of wall. Maksudnya we allow for no rotational fixity at the base of wall. Maknanya dia tak akan berlakunya moment yang fix lah. At this time, the bending moment can produce from the base or from the toe of the wall. So when you apply the additional force here, external force as a A, dia akan give you the deflections. So you apply force here, dia akan ada pengsongan daripada arah daya yang you kenakan from the toe of the wall sehinggalah to the top of the retaining wall. So the base of the wall behave like a hinge, rotate but no displacement. Itu maksud dia. Kalau you nampak kat sini, dia ada deflections tapi deflection dia tak produce any displacement. Dia punya displacement equal to 0. So the active earth pressure behind the entire back of the wall. So mana back of wall? This is the region of the back of wall. So this is we call as the active pressure yang color merah ni. Kalau color biru ni kita panggil dia sebagai passive pressure for excavated soil. So this one is quite common lah. Kalau you nampak kat sini, it's only involved with a homogeneous soil. So bila homogeneous soil, dia tak ada surcharge semua. So only have a idealized earth pressure distribution. It's very easy lah. Dia hanya ada active pressure back of wall and then passive pressure in front of wall dengan satu lagi forces ataupun additional reinforcement A yang ada dekat bahagian wall tersebut. How about the fixed earth method? So as the embedment increase, the moment fixity on the bottom end of the wall is gradually increased. So increase until a point is reached at which the base of the wall virtually behaves like a fixed end of a beam. So the fixed end moment is provided by the large passive reactions acting behind the wall near its toe. Okay, ini adalah conditions kalau kita ada fixed wall. As usual, you kenakan forces ataupun some prop or anchor at A here, dia akan produce to you deflections. But the deflections untuk fixed end wall kat sini, you akan nampak at this post, the moment is equal to not equal to 0. So kat sini dia akan ada nilai moment yang restrain kepada berlakunya any rotations. So moment here is not 0. So you kena tahulah berapa nilai moment yang provide to the these kinds of deflections due to the anchor reinforcement. So the fixed end moment is provided by the large passive reactions acting behind the wall near its toe. So when you refer to the moment distributions ataupun bending moment untuk gambar yang bahagian tengah ni, dia akan produce to you positive zone, negative zone. So compare to this one you akan nampak untuk fixed free end moment kat sini dia mula dengan kosong. Contohnya lah dia pergi ke positive and then dia goes to the negative regions. Tapi untuk fixed end dia dah ada nilai moment. Maknanya dia akan ada negative zone left and right side. The middle is the positive moment. And the earth pressure distribution, this is what we have. So due to this bending moment, the pressure diagram pun akan berubah lah mengikut nilai moment dan juga nilai daya yang bertindak oleh A at top. Okay, for example here, there are two methods used to analyze anchor sheet pile walls. One is a free earth method, the other is the fixed earth method. Which of the methods assume that the depth or embedment of the wall is insufficient to provide fixity at the bottom end of the wall? Sketch an idealized earth pressure distribution and bending moment of the wall for the stated method. So ini antara contoh soalan yang boleh ditanya dalam final lah, part under theoretical. So what is the answer? The first one is the, of course, antara free earth ataupun fixed earth. Jawapan ni adalah free earth method. Kemudian in order to draw the idealized pressure distributions, so you can have from here. Maknanya you letak dia punya conditions. Ini adalah original retaining wall. Kemudian dia ada anchored wall here dekat position A. Kemudian bila you draw dia punya bending moment, dia supposed to be like this. And then the idealized pressure diagram where the active is back of the wall and the passive pressure diagram is in front of the wall. So kalau tengok quite easy lah because yang ni adalah theoretical. But when you go to the calculations, there's a thing yang you kena tengok semula lah. Okay, it is assumed that the depth of embankment below excavations level is insufficient to provide facility at the lower end of the wall. So the wall is thus free to rotate at its lower end. The mode of failure is rotation about the point of application of the tie or prop. So in the design, it is essential to ensure that the available stabilizing moment exceed the distributing moments by an adequate margin. So moment S over to moment D. S tu apa? D tu apa? D2 is the design, D2 is the disturbing moment, S2 adalah stabilizing moment. Of course, bila kita nak design, kita nak yang stabil moment lebih tinggi lah daripada disturbing moment kan. Kalau tak, failure boleh berlaku. So, what is the required depth and H? So, the required depth of embankment D can be determined from the conditions that the algebraic sum of the factor moments about A must be 0. So, this condition yield a cubic equation in D which can be solved by the substitutions of dry values. So, again, yang ni need the help from calculator lah. You set dia punya formula, you setting unknowns until to berapa unknowns kita ada kat sini. Kalau ikutkan sebenarnya yang kita perlu cari adalah embankment depth D. And then H ni most of the time kita boleh ada benda daripada soalan. Tapi because of the conditions for the anchor or prop sheet pile wall is now relates to the cubic equation, so it's not easy or it's not like a linear equation. So dia kena try and error lah untuk dapatkan nilai D sehingga yang mana you set awak punya equation tu sama dengan kosong. Okay, after the value D, the force in T in the tie or prop per unit length of wall can be calculated from the condition that algebraic sum of the horizontal forces must be 0. The bending moment can be drawn. So for quay walls, it is recommended that the depth of embankment depth is increased arbitrarily by 20% to guard against excess dragging. Okay, 5-minute break. Okay, tadi kita berhenti dekat sini. So the purpose of course still kita nak dapatkan the amendment depth. Kemudian nak calculate juga nilai T kan, force yang ada pada anchor or port wall. So the value of D obtained by the method depends on how the factor of safety is introduced into the calculations. So this is affected by the lateral pressure distributions are considered. The active and passive pressure distributions on the two sides are considered separately, combined to obtain the net pressure distributions. So the factor of safety has been defined in terms of the passive resistance available in front of the wall, which gives rise to the stabilizing moment. The factor of safety may be designed FP. Okay, then we go to this figure untuk right side here. Look at to this one, the pressure diagrams. The active and passive pressure distributions of the two sides are considered separately. So kita akan combine bila kita nak dapatkan the net pressure distributions lah. So the passive resistance which must be mobilized to produce the conditions of limiting equilibrium. So by giving that, the PPM is equal to PP. So they can be as a ranking ataupun column divided by the FP. So FP is a passive resistance. So kalau tengok sini dekat bahagian belakang returning wall kita ada active pressure, so KA, kemudian kita ada PA, and then kalau untuk in front of wall kita ada passive pressure, tapi dekat sini you akan dapat the PPM is equal to the passive pressure bahagi dengan passive forces ataupun passive resistance. So the D is the embedment depth that we need to calculate in the equations of the returning wall. Okay, dalam kes ni kita consider the factor of safety mesti equal to 1 lah ataupun lebih daripada 1. So mana-mana geotechnical applications, for example returning wall ke ataupun slope stability, the factor of safety must be equal or more than 1 lah. So yang tu akan consider ataupun we can say that the structure is safe. So the active pressure behind wall change to the passive near the two. Ini yang berbeza kalau some cases yang melibatkan moment. So the passive pressure in front of wall changes to active near the two. This is this is to explain to you the changes from the active to the passive, from the passive to the active. Due to additional embedment depth arising from factor of safety more than 1, results in the reverse pressure profile which generates the partial moment physicity. Dia dah sampai ke tahap moment pula. Okay, dalam kes ni, you kena tengoklah dia punya pressure diagram dulu, dia punya shape dia, kemudian macam mana dia berubah daripada active pressure to the passive, and this is how can give to you the idealized the pressure actually happens behind dan juga in front of the wall. So the behavior of anchor wall is also influenced by the degree of flexibility or stiffness. So bergantunglah kalau kata material tu daripada steel or material tu ada different stiffness E, so they will give you different behavior of the deformations of the wall. So for flexible sheet pile walls, the redistributions of the lateral pressure tend to take place. This leads to a reduction in pressure on parts of the wall which move the most and an increase in pressure on the parts which move less, viscosity of the tile below excavations. Ini dia punya tile dia, so the changes can be seen from this diagram at the bottom. So this distribution take place as a result of arcing. Maknanya ada some forces lah yang kita letak dekat returning wall tersebut. If the stiffer wall such as diaphragm wall ataupun apa benda yang kita apply dekat sini, so the arcing is less significant. So it depends on types of wall lah. If you have the diaphragm walls, senilai itu kita boleh ignore lah sebab tak berapa very significant. In terms of the design for fixed earth method, the earth pressure distribution near the two of walls similar to cantilever sheet pile walls. It increases until a point is reached at which the base of the wall virtually behaves like a fixed end of a beam. So dalam structure, I think that you pun dah belajar kan kat macam kita nak lukis dia punya shear force diagram, bending moment diagram, kalau melibatkan free support ataupun roller support ataupun fixed end support. So similar to here, the only thing is that structure yang kita apply kat sini sebagai retaining wall. Retaining wall tu juga dia punya support sekarang ni kita panggil sebagai fixed end support. So the fixed end moment is provided by the large passive reactions acting behind the wall near its toe. So mana behind of wall? Ini adalah wall awak. So this is the behind of the wall. So you can see that the large passive reactions at the toe of the wall. So this is from the active in the red color to the dash blue color that show to you the deflected shape and lateral pressure distributions of the fixed end wall. So, kat situlah perubahan bila adanya you nak tengok behavior of wall from the free end wall to the fixed end wall. Of course, dia main dengan moment diagrams lah ataupun the effect of the moment to the earth pressure distributions. Okay, what are other things? For a prop earth wall, overall stability in terms of rotation about the prop positions are only applicable to the free earth support conditions. So where fixed earth condition applies so long as the wall is adequately propped and also designed to resist the shear forces and bending moments acting upon it. So there is no failure mechanism relevant to an overall stability check. So the fixed end moment is provided by the large passive reactions acting behind the wall near its toe. So same as explanation just now. Okay, consider the prop wall under fixed end conditions. So the horizontal force and moment equilibrium equation can be generated from here. So the equations of equilibrium are almost identical to earlier equations for cantilever condition but with additional terms accounting for the effect of the prop force. So tadi kita nampak as a A, right? The A is actually produce to you a force. So yang ni force yang kena calculate sekali lah dalam calculations untuk dapatkan the embankment depth. As part of it, you can see that the center of rotations O above O dan juga below O pun dia akan bagi different patterns of the pressure distributions lah at the back and also in front of the wall. Daripada aktif tukar kepada pasif di bahagian belakang tembok penahan ataupun di bahagian depan you akan nampak dia berubah daripada pasif ke aktif. That's example. Okay, then we go to the equations yang mana kita boleh dapatkan ataupun kita can generate from the earth pressure distribution from pole force dan juga moment. Apa yang terhasil adalah, okay, remember bila kita nak dapatkan force, it is the area of the pressure. So you kena tengoklah berapa pressure diagram yang kita ada, kemudian what is the KA, KP, and then what's formula ataupun apa parameter-parameter lah yang kita boleh masukkan untuk dapatkan nilai forces pada keseluruhan diagram tersebut. For example here, because of kita consider the net pressure diagram, so from the active and passive in one equation, so this what exactly generated from here. So for example, kalau from the beginning we have the half, so as I said lah, it's a area of the diagram kan, setengah darab dengan KA, gamma darab dengan, this actually is the effective depth dia. So gamma darab dengan effective depth is the vertical stress darab dengan coefficient of lateral pressure, dia akan bagi you active earth pressure. So darabkan dengan setengah, dia dah tukar kepada force, dari pressure dia tukar kepada force. So ini baru satu diagram, kemudian dia masuk lagi diagram yang lain, dapatkan the effective depth untuk hasilkan pressure force. So these are the things that you can be considered from the whole picture of the anchor fixed earth wall ataupun fixed earth method here. And other than that, apa yang kita boleh keluarkan adalah moment equilibrium equations. So the moment equilibrium equations is taking from here as a force, and then you multiply dengan perpendicular distance. So from all the diagrams here, finally what we can have is that is some stated here lah dengan 3 unknowns with the 2 equations. So nampak kan bila ada 3 unknowns dengan 2 equations, sebenarnya dia cannot be solved easily lah. So something that you need to do by try and error lah. Masuk satu nilai, dapat tak sama dengan kosong. You kena buat simultaneously ataupun you substitute the equations. So there is no unique solutions. Infinitely large number of combinations which can satisfy these 2 equations. Prescribe the force P and then solve the values of D and Z. Repeat with several values of P to obtain several combinations of P, D and Z which can ensure the stability. So select the set value that is economical. Okay, what is the economical? Economical in terms of the design, in terms of dia punya height, length, in terms of the D and Z and also the P. So itu belum lagi kita kaitkan dengan stiffness. So maknanya design you mesti behave like economical lah. Dia tak ada waste in terms of the depth. Tak ada yang kena potong material kan sebab kita nak meet the depth of embedment. So macam mana nak dapatkan economical? So you kena dapatkan the exact embedment depth supaya dia bersifat ekonomi. Economy in terms of the design solutions lah. Berapa banyak solutions yang you ada dari segi value of P, D and Z. Kemudian in terms of the cost lah. Imagine that bila you nak buy this kind of construction material. So mana this kind of parameter designs yang boleh bagi you the best solution in terms of economical. So economical design lah yang paling penting dalam mana-mana construction project. So the approach can be applied to the simplified pressure distribution considered earlier for the cantilever wall. Okay, these are the conditions untuk pore water pressure distribution. Actually ada 5 conditions. So you can have by own readings lah untuk look at the differences between condition 1 until condition 5. So again bila you construct on site the water table or water pressure effect something that cannot be avoided. Tambah-tambah sekarang ni musim hujan kan. So kalau it's more challenging lah when you do the construction activities in the rainy seasons kan. For example consolidations ke ataupun melibatkan excavations ke kan. How are you dealing with this kind of problem? Unprecedented issues yang kita pun tak boleh nak agak ataupun estimate. So the thing is that it shows you the different patterns of the pressure diagram, pressure distribution with the effect of pore water pressure. So yang ni pun saya tak go through lah. I leave it to you to have your own readings. Okay, this is a kind of example yang mana you need to determine the requirement depth of embedment for a factor of safety 2 with respect to cross passive resistance and the force in each type. So kalau kita remember balik to the gross passive resistance, it means that dalam passive pressure calculations tu dia dah masukkan nilai factor of safety. So dalam slide saya tak pastilah slide ni saya bagi pada awak ke tidak lah. Tapi I think that you can go through by yourself lah how to first of all draw the pressure diagram related to the soil problem or the soil conditions. Kemudian first as usual you kena tengoklah apa lagi requirement dalam soalan tu minta. Other than that parameters are given to you untuk you masukkan dalam analysis and design. For example here Phi is 35 degree, kemudian active lateral earth pressure daripada formula you boleh dapat 0.27 and Kp is 3.7 and then you draw the pressure diagrams. So this is quite easy because it's only involved dengan homogeneous dan some sort of the effect of water table. So kalau you tengok sini, the water table is acting. Let us read here. Anchor ship by wall is constructed by the driving line of pile into a soil for which Unit weight above the water table is 17 and the characteristic. The front of the wall is excavated to the depth of 8. Tie rod space at 2.5 are located 1.5 below the ground surface. The water level in front of the wall and the water table behind the wall. Okay, for these conditions, water table berada di kedua-dua side, left and right side ataupun at the back and in front of the wall. So you kena masukkan the hydrostatic pressure in the calculations. So dalam kes ni, there's another additional pressure lah. Dia bukan daripada unit weight of the soil saja. So at this part, when you look at in front of the wall with the passive resistance ataupun passive pressure, so dia dah ada the factor of safety 2.0. The factor of safety 2.0 ni you kena masukkan dalam calculations you dalam passive pressure lah. Just same to the what we have in the gross pressure method. Okay, you list out all the forces involved from the all diagrams 1, 2, 3, 4, 5 and 6. So look at to here 6 kat sini, kalau you tengok is a passive resistance kan, passive pressure. Factor of safety dia dah embed at this part. 3.7 bahagi dengan 2 factor of safety, darab dengan 10.2, darab dengan D power 2. So again, how many unknowns do we have here? So kalau ikutkan kita ada unknown D dengan T sebab dia dah bagi tahu kan high above the excavated soil 8. So Z tu tak ada issue lah sebab kita dah ada nilai dia. So daripada 3 unknowns, we only have 2 unknowns which are T dan juga D. So when you finish all this part, you dah dapatkan moment equation, force equations. By using the algebraic sum of forces for D, you akan dapat embedment depth is a 4.90, whereas the tie force is a 98.5 kilonewton per meter. So the force in each tie rod is a 246 kilonewton. So yang ni dia dah mention what is a 2.5. 2.5 can be found from the questions here. Tie rod space at 2.5 meter are located 1.5 below the ground surface. And then the forces that act to the tie rod here is equal to 246 kilonewton. So some forces bila you apply lesser than here, dia menyebabkan failure lah ataupun collapse of the soil. So kalau you provide more, it's more safer lah. If you see just now, kalau boleh kita nak dapatkan the stabilizing moment ataupun stabilizing forces larger than the disturbing moment ataupun disturbing forces. Okay, for the sea pressure dan juga anchorage ni, yang ni pun saya dah stated lah. For additional knowledge about the anchorage, you can go to this slide, the last slide here. You can see what are differences. Selalunya anchorage ni you boleh nampak on the rock surface ataupun in any highway, expressway plus expressway tu kita boleh nampak some kind of the application anchoring ni. So selalunya dia relates to the weakness plane of the rock lah. Kita nak anchor between different weakness planes on rock, then kita nak strengthen kan menggunakan satu medium of the structure iaitu kita panggil sebagai anchor structure. So I think that's end my presentations this morning. Do you have any questions on this part? Or I may ask you a few questions from here. Okay, I like some opinion. What do you think about on this retaining wall from your personal own observations? Kat mana agak-agak ni lah, mungkin dulu you pernah buat latihan industri kan, ataupun you pernah buat practical kan, internship tu. Ada tak siapa-siapa terlibat dengan projek yang menggunakan this kind of geotechnical applications? Muhammad Rosyam?
Tak ada.
Tak ada Sebab apa tau, macam saya beritahu awal kan, dalam subjek ni, dia ada satu projek tau berkaitan dengan geotechnical applications. It's some sort that you dump all contents in CEG 612 into one project. Maknanya project tu adalah outcome, sebahagian outcome yang kita nilai daripada contents topik for CEG 612. From the beginning of the theoretical about more column, the stress pass, and the input parameters, etc. Maknanya nanti kan bila project you ni from now on pun, sebabkan minggu depan dah midterm break. Betul tak? Minggu depan midterm break.
Betul madam.
Betul kan? Ke saya seorang je yang excited tunggu midterm break? You all biasa je. Okay, minggu depan midterm break. Maknanya apa yang saya nak pesan dekat awak, sekejap eh. Okay, apa yang saya nak pesan pada anda semua adalah untuk kenal pasti mana-mana potential projects lah ataupun project FIPU lah kan, siapa yang buat FIP yang menggunakan tool, computer program ke numerical modeling and simulation, you can adopt this same method untuk you punya project CG 612 lah. You identify problems, kemudian you solve menggunakan numerical model. Numerical model ni you can start off dengan ada Praxis ke, ataupun our last class tu saya dah bagi satu nama software kan, SPW. SPW ni some sort of the software untuk you analyze the returning wall of the soil lah, untuk you tengok kalau kata backfill banyak ni, kemudian dia tak ada anchor wall, dia tak ada prop, or dia tak ada tie rod semua tu, macam mana kita nak dapatkan dia punya factor of safety ke, macam mana kita nak tahu dia punya pressure behind or in front of the wall. So from now on, you dah sepatutnya mulalah thinking of the project. Apa problem yang you nak bawa masuk dalam projek you untuk you selesaikan. It becomes the whole output lah untuk sebahagian daripada assessment CG 612. That's why lah daripada apa yang kita dah belajar daripada week first until now, actually you dah slowly thinking lah how to make this report project dia relevant untuk CEG 612 Advanced Geotechnical Engineering. Walaupun you tak cover lagi on part of the numerical modeling and simulation semua tu, tapi you dah boleh carilah some cases lah, problem study ke, case study ke untuk you jadikan your project. And then Google lah, search lah sikit kan, sebab minggu depan dah cuti. Tak naklah main terkejut-terkejut last minute baru submit, kemudian submit pula tak cukup requirement. Walaupun saya tak keluarkan official requirement criteria untuk project, but I have give you some sort of the introductions about the project kan. So dapatkan sedikit lah masalah problem geoteknik ke. Kalau you ada kenalan yang dah kerja ke kan, get the contact from them. And some kinds of geotechnical analysis, macam mana dia analyse returning wall punya embankment depth, ataupun ada tak some calculations untuk factor of safety. So that's some ideas lah untuk you move on to the next week punya project dan juga topik. Tak silap saya, minggu depan, lepas midterm break, kita masuk chapter bab apa pula? Agak-agak ni apa ya? You all ni dapat 7 tau. Okay, kalau lepas midterm break ni, 22 hari bulan 11 cuti, kemudian kita masuk balik 29 bulan 11. So jangan terkejut lah kalau tiba-tiba saya more column year criterion tu saya minta you all present pula. Sebab dia masuk chapter 1 kan. So lepas cuti kita masuk chapter 1, remaining topik more column year criterion, yang mana dia sepatutnya cover dalam test hari tu tapi tak cover kan. So yang ni saya nak you all bersedialah, cuba study sikit pasal kriteria ni, apa pentingnya, apa tak pentingnya, what are good about it and what are bad about it. And after that baru kita masuk chapter 4, numerical model and simulations. Lastly baru chapter 3. So you nampak kan, masa bergerak pantas. So don't wait until it comes to you. Okay, I end my class today. Any questions? Ada soalan tak?
Tak ada madam.
Okay, jangan lupa buat learning activity. Hari ni, minggu ni satu soalan je. Kalau you all perasan soalan tu saya dah bagi dah solution. You cari lah solution dekat mana-mana. Okay, Assalamualaikum
Okay, madam.
warahmatullahi wabarakatuh.
Okay, thank you madam.
Thank you, Dr.
Waalaikumsalam. Thank you, madam.
Okay.